Can you speak up? I cannot hear you.
Yeah, any tie-up with HSMC? It would be Visa Internet Navigator.
Can you keep my mic? I cannot hear you still.
It's fine now?
Yes.
Do you have a tie-up with HSMC?
PSMC? HSMC? Not yet. I mean, again, the thing is, that's something we want government to step up and go to the leading nodes. We still feel there is a gap out there. Most of our stuff is going on to the most leading foundries, TSMC, Samsung, and global foundries. But yeah, once HSMC come to a fruitful state, we'll definitely partner with them.
I mean, they are not in good shape. Partnerships.
Sorry,
No, I mean, they are not in good shape right now.
I cannot hear you still.
HSMC is not in good shape right now.
I cannot comment.
This may have been a question for the previous presentation, but you, in one of the slides, you had talked about some Series 7 and targets for the networking space and vertical. What kind of application that you have? Is it like switches and routers that you
So switches and routers predominantly don't have a big 64-bit Linux application requirement, but more on the networking side you will find is the 5G based base stations, where you are doing more, kind of SOC type environment. Switching and routing is mostly built around the data domain, so you don't have big CPU on that.
Coming from Hewlett Packard and Ericsson, we have a lot of data path multi-core that is used in the line cards.
Yes.
So that is not the
No, routers have, I didn't mean to generalize it, but like some of the routers, they use, I've seen some instantiations where they're already moving from like A53 class to like a 74 class. So that kind of.
So the Series 7 that you were talking about.
It supports that.
It was mostly for what kind of networking application?
Yes, it supports. We did show in one of the slides, it's almost equivalent to an A53, A55 kind of stuff. Right? So if you are using something on that front, U74 is a really equivalent to that.
Thanks.
Thank you.
Now we come to one of our partner presentations on the concept of this package today. From Agnesys. Agnesys is headquartered in Boston. The R&D center in California and Noida. They develop EDA software that helps teams create SOC faster and effectively. Anupam is founded the Agnesys 12 years ago. He has been in the industry for more than 25 years, helping team automate their development process. He will present on designing IP device drivers for RISC-V.
Thank you so much. Can you hear me? Okay, great. Well, after lunch, and I know I'm feeling a little bit down, but I'll try to spice things up. So, Agnesys, how many people here know about Agnesys? Or just one? That's good. So I have a lot of new people to talk to. That's great. So, okay, so Mohit already asked this question, so I'm not going to ask you. So it looks like there are a few people doing IP development. How many people doing software? And verification? A few people. You guys talk to each other? Okay. All right, so my presentation is about how to improve the development process. You know, we talked about IP and the CPU. How do they connect together? How do you create the SOC? Creating the SOC is a high-stake game. and it requires too many engineers, too many machines, too many resources. How do you reduce that, right? It requires too much time as well, and it just has too many steps along the way. So how do you automate? So this is something may have happened to you in the past. You might have seen this on the net. I didn't create it, but I just borrowed it for this presentation. So you have a marketing or business specification that comes along that they want to do something like this. And then RTL designer implements something like this. And he looks at the spec and that's what he understands. And then the verification team verifies this. And then it comes to software team. And then turns around the driver team and the software team. As you see, things are going out of hand, right? Things are going in a certain direction. But the technical publication team, they're like very good. They're like all nice, nice thing that they've created, like a big roller coaster. And that's what finally the customer gets. But really, what the customer wanted was something like this. So why did this happen? And it's because there's too many stages in the game. In that high stakes game, there are too many points where information has to be communicated. People look at something, interpret it in different ways. So how do you avoid that? How do you reduce time to market? You use proven technology. We're here with Sci-Fi, so shout out to these guys. Sci-Fi guys, so use stand on the shoulders of giants, people who have already done that. Use templates, use proven IP. Mohit was talking about templates, so yeah, absolutely, use template-based designs and automate as much as possible. Even if out there, this is like a call out to the managers who say like, why is your stuff not done? I would say let the engineer do extra work, but let him automate. Often that's a challenge. People don't want to spend time in automating. They'll like, put another person on and let them do the work. So spend extra time doing automation. Eliminate wasteful and manual and duplication of work. And this is the most important. Use single source of information. If you have any place where you are putting the same information twice, that is bad. I've seen in all these years, if you spend that extra time in using single source of information, that pays for itself over time. So do not duplicate that. So if you see, this is what we're after, is creating an executable specification from which you can automatically generate code for hardware design, verification. Actually, it was a little bit off, but you understand what I mean. So design, hard verification, all through software, firmware, everywhere. So let's look at now a typical SoC. You have the CPU with the brand new ISA. So the ISA is the hardware-software interface, the HSI. But what about the IP? There's the interconnect fabric, and then you have the IPs and memory. All these are accessed by the CPU through these CSR registers. And then there are interrupts and pins as well. So they constitute the hardware-software interface. So basically, creating this, managing that hardware-software interface is important. Not just within the CPU, but outside the CPU as well. And there's no, there are bus standards, but there's not much in that area right now. But that's what we're trying to address. So what we help with is kind of, those registers become very important. How the CPU communicates with the IP. So we help create that single source of specification and generate everything from it. Dealing with all types of registers, like these are some of the software. So when I say software access, I mean how the CPU is accessing it. There could be, there's not just simple registers. There could be a lot of behavior associated with those registers, right? There could be, for example, I've listed a few here. I know it's a full slide, but the idea is, the point I'm making is, it's not just simple read, write, or read only. I mean, some people think CSR registers are that's it. But there's a lot more that can happen. You might have like locking registers, or maybe there are shadowed registers. There might be, of course, indirect. There are interrupts, right? Or counters. So there could be all kinds of things. The way the CPU talks to the IP, and then your application logic hooks to these registers. So behind these registers is your actual application logic. So the idea about the single source is that you create a single source and then generate everything from it. So for example, the RTL model. You generate the RTL model, you create the C++ API, maybe a RISC-V ASM model as well. I'm not 100% sure about that, but that is a possibility. System C as well. Many people do virtual prototyping in this space. So you can generate system C. Verification, the RAL, that's pretty standard, creating the UVM-based register abstraction layer. So agents and drivers. Of course, the documentation. Stuff that nobody pays attention to, that could be automatically generated. And then, custom outputs like, you want to create something special, you can use other ways of generating output as well. So this is kind of the solution that we provide. Is like you take in these industry standard ways of describing this register abstraction layer, system RTL and IP exact, or there could be like your own, like the IP vendors that Mohit was talking about. Maybe they have their own kind of standards. They could be using IP exact, but sometimes IP exact doesn't cover all the behavior part that I was talking about. So there could be additional properties that go in to describe that behavior. So as I was saying, single source could be a Word document or an Excel or an open office file, and then generating everything at the bottom. The two sides just indicate an interactive, maybe a cloud-based. What I'm showing here is a desktop application, but it could be a cloud-based application or a batch mode CLI-based application from which everything is generated. So in addition to that, advanced issues need to be addressed, like clock domain crossing. When you are integrating IP with the CPU, you might have in the IP functional safety. You might be targeting the automotive market. That might become important. Variations. Variants are like different variations based on like which customer your end customer might need different things coming out. So clock gating for power optimization and hierarchical decoding. So all these issues need to be addressed, and we have addressed these. So this is an example of a template base. Again, Mohit mentioned template. So we have been doing this for last many years. So templates for registers and IPs, and customizing them in like in a Word document or online, and then filling up things. So good thing about template is you can ask user to enter certain things, but he automatically gets the rest automatically. Right? So point is that it's a limited freedom that you give the customer. It's not totally free to do anything they want. They can customize it a little bit. Similarly, like Excel-based document, or like a desktop application. Or like I said, I don't have a snapshot, but there's a cloud application which is very similar looking like this. So capturing this spec at a high level, single source, not duplicated. All right, so this is, in addition to that, we have standard parts as well. So highly customizable GPIO, PWN, all that you saw. But again, the point here is that what we bring to the table is that they can be highly configurable and customizable. Like the registers that the GPIO will create, you can integrate with them very easily. So again, like a template-based approach, and we abstract the register bus. So we already support the legacy, I would say, ARM-based buses, but now with the tiling, so we do support tiling, and which is being now promoted So here's an example of a GPIO with configuration and customization. So you select the number of pins and you get the standard registers, but then you can also add custom registers to it and kind of integrate them. So maybe you have some special things. Maybe you have an interrupt which has a detector on maybe like an overflow detection on an interrupt. So things can be customized really with these template-based rules. Okay, so what I talked about registers also extends beyond that. It's not just the hardware, but also the software. So if you see the registers, the interrupts, the pin, they constitute the core hardware, and then there is an abstraction layer around it. Those are the device drivers on which the application layer is built. So creating that device driver is very tedious. All this interaction between the design people and the verification people and the software people, it becomes very tedious. Device drivers are typically created in C and ASM, and the functionality is really created by is imagined by the hardware team, but it is used by everybody else, right? So by verification and emulation team, so kind of say the order of initialization, for example. That could be the hardware guy imagines it, codes it, but then the verification people have to kind of go through that same sequence. Emulation, prototyping, firmware, and finally the validation team have to also go through this. Everybody who is testing it has to do that, right? Follow the same kind of process. Everybody has their own language, right? All these different teams have their own languages. So that's how it is. You've seen this before? Elephant with 9 blind men. Everybody's trying to figure it out what it is. And actually, I've replaced what they say with my thing. Like they're trying to figure out the SOC, how it works. And one person says it's like, oh, write this register first, and no, this one first, or they're just trying to figure it out. Everybody's like confused and clueless. So, idea is to bring the same single specification in this. So, basically create one specification and generate everything again in this space as well. So, so if you look at sequences, which is what I'm saying, like abstract the sequences. You have 2 types of sequences. One is functional, and the other is test. So functional, by functional I mean like the device driver sequences. And test is like how you are verifying from the outside. So having a single source of sequences is very useful. So create. So one of the ways that we help is like you can create a low-level like Python sequence and then generate everything from it. Like for example, you can create from a single specification. So that sequence specification is like a pseudo-code from which you're generating like verification sequences, UVM sequences, or even PSS, the latest portable stimulus standard. I'm not sure how many of you know about that, but anyway, so that's the latest that is happening in the verification land. Similarly, emulation and prototype, you might need a MATLAB environment that where you are generating those MATLAB sequences. Of course, C or RISC-V ASM. I'm not sure about the RISC-V ASM, but that's what we're trying to find out, whether that helps there or not, or whether it's the job of the compiler to do that anyway. So just C is enough. But it's possible to generate RISC-V ASM as well. You can come up with like a reason for doing that. One thing that it could help is like you might change precision. Some people asking about precision. So it could be like when you're generating ASM, you focus on different different areas of that ASA. So here's an example. Like this is GPIO registers being programmed in Python. And then from that we create like SV UVM for verification, C for firmware, and even the portable stimulus stub that can enable you use the portable stimulus standard. So portable stimulus standard, if you know about it, basically deals with at a higher level. It doesn't go down to the implementation layer. So having a methodology like this, you can create not just for portable stimulus, but also that same sequences can be used by your verification team and firmware. And so, in summary, the single source methodology reduces risk in this high stake game. And overall, it reduces your time to market by 40 to 60%. And we at Agnesys have fully customizable IPs ready for RISC-V whenever you need it. And these are some of our customers' testament to our success in this industry. And we're happy to help. And we have a table outside. We're going to stop by, take a closer look, and answer any questions. Questions? Very clear. Everything is clear? Or nothing is clear? Or you want tea? Great. Okay, thank you.
Thank you.
That brings to our afternoon keynote presentation of Microchip. Microchip is the co-host of today. Microchip is also a very early supporter of RISC-V. They work closely with Sci-Fi. So, KK, R. Kumar is a V5 ecosystem